the topic of today's video is a difference equation and its formation, right? So I will start with the formation of the simplest difference equation by a very simplest example, and for it you can consider a sequence of numbers, right? And if I write a sequence, consider a sequence of numbers 3. The first number is 3, right? The second number is 3 square, then 3 cube, and so on, right? So the question is, what will be its nth term, right? Rather than writing its nth term, if I see the pattern and we observe that the nth term, any term, is equal to 3 times its previous term, n minus 1th term, right? This pattern is clearly visible from here, right? So you can write it as, if I denote the nth term by yn, right, it will be equal to 3 times the n minus 1th term, right? And this pattern is visible from second term onwards. You can say that the second term is thrice the first term, third term is thrice the second term, and so on, right? So I should mention that this rule is valid for n equal to 2 onwards, right? For n equal to 1, this rule is not defined, because you cannot say that the first term is thrice the term appearing before it. That is absolutely wrong. So this rule is valid for n greater than or equal to 2, right? Or you can write it as in this way: yn minus 3 times of yn minus 1 equal to 0, and for this n greater than or equal to 2, right? This is called the difference equation, right? Or you call it a recurrence relation. I will write it here. This is the difference equation or recurrence relation. Both of these terms are used frequently, right? And one more thing, what about the first term? Because this rule is valid for second term onwards, so first term should be given explicitly. So y1 is equal to 3, right? And when you say that this is a difference equation or recurrence relation, so we can define it by saying that a recurrence relation or a difference equation is nothing but it is just a relationship between the terms of a sequence, right? Because we have a sequence here. If yn is its nth term, then yn minus 1 is its n minus 1 term, right? So we can say that a difference equation is a relationship between the terms of a difference equation, right? Or you can say that this also, this function yn is called a discrete numeric function. Discrete numeric function, right? And what do I mean by a discrete numeric function? Such function is called a discrete numeric function whose domain, see, the n belongs to its domain. N starts from 1, 2, 3, and so on. It means that the domain of this function is the set of natural numbers, or you can say that non-negative integers. Sometimes the domain starts with n equal to 0, 1, 2, 3, and so on. In this example, the domain is starting with n equal to 1, 1, 2, 3, and so on. So the definition of a discrete numeric function is that a function whose domain is a set of non-negative integers and range is a real number, it can be anything, then we will say that such a function is called a discrete numeric function, right? It is very similar to the function of real variable fx, where x is a continuous variable and we say that fx is a continuous function or real continuous function, where x runs over the real line. Means x can vary from 0 to infinity or minus infinity to infinity, right? That is called a continuous domain. But for a discrete numeric function, right, we have a function which doesn't have a continuous domain, rather it has discrete values 1, 2, 3, and so on. So there is a difference between a real variable function and a discrete numeric function, right? So discrete word is for its domain, right? N belongs to 1, 2, 3, and so on. And again, you recall that the differential equation. A differential equation is nothing but it is a relationship between the derivatives of y with respect to x, right? Similarly, here we have a difference equation, right? And I will try to find the solution of this difference equation. This is just a difference equation. The solution of this can be obtained by just plugging these values here in this difference equation, because we know y1 is equal to 3, then putting n equal to 2, 3 and so on will obtain its terms, and then after finding its 3 or 4 terms, I will try to generalize it to write its nth term, right? So this process I will be going to do is called iteration method to find the solution of a difference equation, right? I will write that here, the solution by iteration method. This is the simplest method to find the solution of a difference equation. Solution by iteration method, or you call it back substitution method, right? So given that y1 is equal to 3, this is given to you, right? So putting n is equal to 2 in your difference equation, this is your difference equation. Putting n equal to 2 will here give you y2 is equal to 3 times y1, right? Taking this term on the right hand side, and y1 is given, that is 3, so ultimately it will become 3 square. Then you will put n equal to 3, you will get y3 equal to here 3 times y2, and y2 is already found, that is 3 square, so it will become 3 times of 3 square, or it will become 3 cube, right? So you can say that you can generalize from here, generalizing, and the nth term should be equal to 3 to the power n, because the third term is containing 3 to the power 3, so nth term will be 3 to the power n, right? And n starts from 1 this time. You can see that if you plug n equal to 1 here, you can always put n equal to 1 here, and the important point is that we are allowed to put that n here at this suffix that doesn't produce a negative subscript, right? So n equal to 1, putting n equal to 1 here will give you 3 to the power 1, that is 3, and that verifies this condition that y1 is equal to 3, that is obviously true. Then put n equal to 2, you will get 3 square, you can see that the second term was 3 square, and so on. So this is the solution of this difference equation, and this is called the discrete numeric function. Again, at this point, discrete numeric function yn is discrete numeric function, right? And however, the original difference equation, the domain was from 2 onwards, but the solution is defined for n equal to 1 also, because the initial condition was also given at n equal to 1. And there is a solution of this difference equation, which is also called discrete numeric function, right? So the important thing is that why we form a difference equation, or we call it a recurrence relation, when we already have a differential equation, as you have studied in your last semester course. Why do we form this difference equation? Because in some problems of real life, where n is this is n, your domain set, right? Where is that n? This is your n, right? In real life problems, this domain set is sometimes discrete, right? Suppose you deposit an amount in your bank, principal amount P, that is called principal. Then the bank gives interest following this difference equation, not a differential equation, because the bank calculates the interest at the end of each year, right? It means that bank forms a difference equation, and then it gives the amount at the end of 20, 30 years, whatever, right? But if the bank start giving the interest per second, or you should call it a fraction of each second, then they will form a differential equation, right? And that is a different scenario, but the actual scenario is that the bank uses the difference equation to give you the interest, or finally the amount, right? So this is a kind of example in which you can see that difference equation is really used in real life. So I will start with the famous example that is called the Tower of Hanoi problem, where this difference equation is used to solve it. So I will write that Tower of Hanoi problem. Tower of Hanoi problem. So in order to visualize that problem, I have to draw the diagram first, right? Right. So this is a diagram for tower of Hanoi problem. This diagram demonstrates that we have three pegs. Pegs is kind of a vertical tower, like this marker, right? You have three pegs on this board, horizontal board, right? And you have these discs. These are concentric discs, right? I have made only 4 of them, but they can be n in number, right? They can be 2 discs, 3 discs, or any number, right? So in this picture we have 3 pegs A, B, and C, and all of these discs are centered at the same point, right? And the disc placed at the bottom is of biggest diameter, and as you move up, right, the diameter goes on decreasing, right? So what is the problem? The tower of Hanoi problem is that you have to transfer all of these discs from peg A to peg C. This is your destination peg, this is your source peg, right? And you can see the order of these discs. That order should be maintained here. The first thing is that, right? And with the following some restrictions, or we can call it rules, right? You have to follow certain rules in order to transfer this whole pile of discs from A to C. The first rule is that only one disc will be allowed to switch one time. You cannot just put 2 discs at a time. You should be allowed to choose at 1 disc at a time, the top disc only, right? And the second point is that the second restriction is that you cannot place a disc over the top of a smaller disc, right? So with the following 2 rules or restrictions, we have to transfer this whole pile of disc from peg A to peg C, and you can use this peg B, right? Okay, so this is the tower of Hanoi problem, right? So this problem can be solved by dividing this original problem into 2 sub-problems, right? Why I am calling sub-problems? My first target is that because I want this disc, see this biggest disc, I want this disc at the bottom at peg C. First thing is that, and to achieve that goal, I will call it a sub goal because I am talking about a sub problem. To achieve that sub goal, I need all of these n-1 discs. These are 3 in number, or n-1. I need all of these n-1 discs here, right? And this biggest disc will be at A, right? So I need that situation. First thing is that. So in order to achieve the complete goal, that is to transfer all of these n discs from peg A to peg C, I have classified the problem into 2 sub problems, right? Again, the first sub problem is to have these n-1 discs at peg B and this last disc at peg A, right? So this is my first goal, right? I will draw that picture first. So I will call it intermediate position. I don't know how many steps would be needed to achieve that goal number 1, but I will draw that picture, right? So the picture will be like this. The biggest disc, this is the biggest disc, this is a peg A, right? And you need all of these n-1 discs here at peg B. I have to make disc first. So this is my goal number 1, right? And you can see that all of these n-1 discs are now at peg B, right? And the last disc is there at A, right? So after reaching at this situation, I will just transfer this last disc from A to C directly, and that will constitute 1 step, right? and after that I will transfer this n minus 1 pile of disk from B to C by some steps, on a number of steps, right? So this is your intermediate situation, and in order to reach this situation you have to perform some steps. I will assume that let Tn denote the number of moves which is a solution of this problem, right? I will write that here. Here. Let Tn denote the total number of moves required to shift or to transfer these n disks from A to C. So Tn is the solution of the original complete problem, right? And if you see this intermediate situation, it appears that to achieve this goal I have to switch these n minus 1 disks from A to B, and that is a kind of sub problem. And if Tn denotes the total number of moves to transfer all these n disks from peg A to peg C, then this number, to achieve this goal I should have used Tn minus 1 steps. That's pretty simple, right? Because you are breaking a full problem into a sub problem, and you can see that these are only n minus 1 disks, right? So to achieve this situation I must have performed Tn minus 1 moves, right? I'm writing that. Okay, I will write that here. Tn minus 1. Here is Tn, right? And why it's Tn? Tn is the solution of the full problem, n number of moves, right? It is an intermediate situation, and plus after reaching this situation I will transfer this biggest diameter peg from A to C, and that will constitute one step, so I have to add one here, right? Now again another intermediate situation, I will not draw that, right? Just remove this disk from here and draw disk here, biggest disk. That will be my new intermediate situation, situation number 2. After having this biggest disk here, right, what is my target? My target is to transfer these n minus 1 disks from B to C using peg A, because peg A will be empty at that time, right? So again that is my sub problem number 2, right? And that is, and the number of moves required to solve that sub problem 2 will be again Tn minus 1, because we are again focusing on these transferring these n minus 1 disks from B to C using peg A, right? So Tn minus 1 will be added again, right? So this Tn minus 1 corresponds to the number of moves which are required to achieve this situation, right? And this plus 1 is for this transfer biggest disk from A to C directly, right? And this Tn minus 1 is the number of steps which are required to shift these n minus 1 disks from peg B to peg C using peg A also. So this is a solution for sub problem number 2, right? So the whole solution is actually the sum of solutions of sub problem number 1 and sub problem number 2, and plus 1. This plus 1 is for this transfer of this biggest disk, right? So this is the difference equation corresponding to this tower of Hanoi problem, right? We have not solved this tower of Hanoi problem, we have just constructed the difference equation, right? So this is how our difference equation is constructed. Do not seek the solution, rather think of any intermediate situation like we have done here, right? And try to construct a relationship between the discrete numeric functions, or you call it the solution of the difference equation, right? But one thing is missing here. I have to supply an initial condition, right? And that initial condition should be, and if you see this, you can add this, and you see this suffix, this is n minus 1, and this is not defined. If I put 0 here, I cannot put 0 because that will produce T minus 1. The first thing is that. So 0 is not allowed in my domain. I will start with 1, right? Okay. So this is for n greater than or equal to 1, and 1, 2, 3, 4 on. It means that you can take one disk, You can take 2 disks in your problem, right? I have drawn only 4 of them, right? Okay, and what about the initial condition? The initial condition should be T1, right? It means that with the 1 disk available here, A, how many moves would be needed? If you have 1 disk at peg A, right? Only 1 move, because in that case you can directly switch that biggest disk or the only disk from peg A to peg C, and that will constitute only 1 move. So that's why T1 should be 1. This is the initial condition that is determined by considering only 1 disk, right? So this is a complete difference equation, or you can add these 2 terms also, or Tn equal to 2 times n minus 1 plus 1, n greater than or equal to 1, and T1 equal to 1, right? So this is a difference equation corresponding to this tower of Hanoi problem, right? And now I will try to find its solution as I did in this example, right? Putting n equal to 1, 2, 3 and so on, and trying to generalize it somehow, right? Okay, so you can see that we are given T1 equal to 1. So I will start with this thing, right? Solution by iteration method, solution by iteration, okay, method. You are given T1 equal to 1, right? So what you will do, put n equal to 2 in your difference equation. This is your difference equation corresponding to this tower of Hanoi problem. Putting n equal to 2 will give you T2 equal to 2 times T1 plus 1, and you can use this 1 here. So 2 times of 1 plus 1, right? Okay. And yeah, if I put n equal to 3, you will have T3 equal to 2 times T2 plus how much? 1, and that will give you I think 2 times 2.1 plus 1 plus 1, and that will produce 2 square plus 2 plus 1, right? I can write it as 2 to the power 1 plus 1 in order to generalize it. You can see the pattern, right? T3 is equal to T square plus 2 plus 1. I will just write one more term, n equal to 4. This will give T4 equal to 2 times T3 plus 1, and on plugging the value of this T3 here, I will have 2 times 2 square plus 2 plus 1 plus 1. So that will ultimately give you 2 to the power 3, 2 square, 2 to the power 1, and then 1. So now I am in position to generalize this, right? I will write the nth term, generalizing. You will get nth term will be equal to, if you see this is T4 and you start with the power 3. So T2, 2 to the power n minus 1, then 2 to the power n minus 2, and this power goes on decreasing up to the last 2 terms are 2 to the power 1 and 1, right? So this is your Tn. Now it remains to just find the sum of these infinite series. This is not infinite, sorry. This is these are n terms. If we focus on the power, this is 1, 2, 3, and so on. 1 to n minus 1. These are n minus 1 terms up to this term, and add this last term. So ultimately, I will be having n terms on the right hand side, right? But I should write that this series in reverse order in order to apply that formula of GP. You can see that this is a GP, right? Geometric progression. Where the first term is 1, and the ratio is obtained by dividing the successive terms. Second term upon first term, you can get 2. Third term upon second term, again we are getting 2. This, it indicates that it is a GP, geometric progression, and the sum is given by A, the first term, and see the ratio. The ratio is 2, and that is greater than 1. So r to the power n minus 1. Why this n? Because these are n in numbers, right? This is n minus 2, this is n minus 1, sorry, right, over r minus 1. So ultimately it will give 2 to the power n minus 1. This is your Tn, this is your solution, right? And you can see that this solution is defined for all values of n, right? N greater than or equal to 1. You can always put 1 here. You will get, if you put 1 here, you will get 2 to the power 1 minus 1. That will give you 1. It means that for one disk available at A, only one move is required. That is absolutely true, right? Is a solution. Is solution. right? And this is a discrete numeric function corresponding to this difference equation, right? And you can visualize, or you can draw the diagram for n equal to 2. That is also easy. If you have only 2 disks here, 2 disks, imagine that we have only 2 disks here at this position, then how many moves will be required? And the first move will be transferring this top disk from A to B. That is the first move. And the second move will be transfer of this biggest disk from A to C, right? Okay. And the third move and the last move will be transfer of that smaller disk from B to C. So ultimately I will be having 3 moves, right? You can visualize this process. And if you put n equal to 2 here for 2 disks, so your answer will be 2 square minus 1, that will be equal to 3. So this is indeed the solution of this difference equation, right? But for larger number of disks, finding the solution manually is difficult, right? So the smart choice is to obtain its difference equation and find its solution, and then plug n equal to 2, 300 and 1 lakh, any number, right? Okay, so I will take another example, the simplest example, the example of calculation of interest in a bank. I will take that example. So example number 1, find the amount after, I will say, 12 years, right? If a sum of rupees 100 is deposited at the rate, I will say, 5% per annum, compounded annually, right? And as I said earlier, that a bank calculates the interest or the amount by using a difference equation, not a differential equation, right? They consider their domain as n equal to 1, 2, 3 and so on, right? So what I will do, I will try to form a difference equation using this situation, right? And let n denotes the amount obtained by the consumer, right, after n years, right? And the principle of getting amount, or you can say the bank works on the formula. The formula is that the amount obtained after nth year is actually the this sum of amount obtained after n minus 1th year, right? And then this 5% interest calculated on that amount, right? As you know that if you want to obtain amount after 12 years, then the calculation of bank is as follows. The amount obtained at the end of first year is treated as a principal for the second year, right? And the amount obtained after second year will be treated as a principal for the third year and so on, right? And this rate of interest is calculated on that principal amount, right? So after 12 years, right, the amount obtained after 11th year will be treated as a principal for the 12th year, and that 5% calculation will be done on that principal, and that will be added to the 11th year amount, and that will give you the amount after 12th year, right? So this is the kind of rule that bank uses to calculate the amount, right? Okay, so what I will do, I will just simplify it. An equal to an minus 1 plus 5% of this, that will give you 0.05, I think, yeah, an, and then an minus 1, sorry, and then adding it, I will get an equal to 1.05 times an minus 1, right? And I can take this term here also. This is also fine. This is the difference equation, and you can see that this difference equation is not valid for n equal to 0. If you plug n equal to 0 here, you will get a negative subscript here, so do not include that number, and is greater than equal to 1 again, right? And one more thing, where is the initial condition? Again, the point is that the initial condition can be obtained by thinking this thing with a naught. And what is this a naught? A naught is nothing. A naught indicates the amount obtained after 0 years. It means the principal, the amount you deposited in the bank, and that's called the principal amount. That is called the principal, and that is how much? Rupees 100, right? So this is a complete difference equation in order to get the amount after n years, right? And in order to find its solution, however, the solution is not required in the question. Oh, solution is required, sorry. This is a difference equation. So in order to solve this, what I will do, I will again use that iteration method, right? Solution by iteration method, right? So you already know what do we do in this. Since we are given this a naught is rupee 100, right? This is the principal amount. Okay, then putting n equal to 1, 2 and 3, you will get the successive amounts. A1 will give you A1 equal to 1.05 and A naught, and this A naught is 100, so 1.05 times 100 rupees, I will write it here, and n equal to 2 will give you A2 equal to 1.05. Where is that difference equation? Yeah, A1, and putting this value of this A1 here, I will get 1.05 whole square times 100 rupees. And you now I can generalize this process. Generalizing, an should be equal to, where is it? An, yeah, an. We should have 1.05 whole to the power n 100 rupees. So this is the solution of this difference equation, and you can see that this solution is valid for all n. You can put n equal to 0 here also, n equal to 0, or n should start from 0 onwards, right? So this is the solution of a difference equation. If you plug n equal to 0, you will get 100. A naught equal to 100. You can see that this is also verified from here, right? And what do we want? We want the amount after 12 years. So I will put 12 here. Put n equal to 12. You will get A12, that is the amount obtained after 12 years, will be equal to 1.05 to the power 12 times 100. So this much amount will be obtained by the consumer after 12 years, right? And now I will give the classification of this difference equation, and this is very similar to the theory of differential equation. Just as a differential equation can be classified as a linear differential equation or a non-linear differential equation. I am talking about the ordinary differential equations, right? So the theory goes the same, right? I will write those points here. So classification of a difference equation, or you call it a recurrence relation, right? Okay, so I will start with the general linear difference equation, right? So a difference equation of the form, and I will write a kth order, yn plus k plus p 1 is a function of n, and yn plus k minus 1 plus p 2 n y n plus k minus 2, and it will go up to pk, yeah, pk n y n equal to f of n, right? I will call it equation number A, right? Okay, and where these p1n, p2n, pi, I will write I for all 1 to 3, where I runs from 1 to how much? K, right? And fn, the right hand side function, are functions, or we should call them discrete numeric functions, right? Because function can be a real function or real variable function, but here we have a discrete numeric function. whose domain is just a set of non-negative integers, right? So by function I mean that discrete numeric functions, right? Continuous functions are not allowed here. Okay, Fn are functions of variable n, right? So this is called a difference equation, and yeah, it is called a linear difference equation because you can see that yeah, only product terms are not allowed here. Pin are the functions of n, that is fine. Fn is a function of n, right? I will write that point rather. Is called linear difference equation. And why we are calling it linear? Because the product terms of discrete numeric functions are not allowed here, or you can say that the powers of a discrete numeric functions are not allowed. Had their square, had we have square here, yn plus k whole square, then this difference equation will be a non-linear difference equation, and this is again very similar to the theory of differential equation. A differential equation is said to be linear if there are not product terms of derivatives, right? Or you can say the power of derivatives doesn't appear in your differential equation, then you call it a linear differential equation. So this is again the same thing, right? You are not allowed to multiply two discrete numeric functions. You cannot multiply y1n or y2n, right? Because that will produce a non-linear difference equation. Okay, and if these pin, especially p1, p2, and if these are constants, I will write that point. If pin, I runs from 1 to k, are constant terms, right? Then we say that this linear difference equation is a difference equation with constant coefficients, right? Then equation number A is called linear difference equation with constant coefficients, right? And yeah, one more thing, the important thing is that the order of this difference equation, just as we find the order of a differential equation, the order of a differential equation is the order of the highest derivative appearing in that differential equation, and in this case difference equation, the order is given by the difference between the highest subscript of y and the least subscript of y. You should subtract these two, right, to get the order of this difference equation. So I will write the order of this equation number A, that is given by n plus k minus n, that will be equal to k. So this difference equation is of order k, right? Okay, and again the same theory. If we have this Fn is equal to 0, right, then we call it homogeneous. If Fn equal to 0, the function appearing on the right hand side is 0, then this difference equation is called homogeneous difference equation, right? Then difference equation, or I will write A is homogeneous, right? Then A is homogeneous, right? And if Fn is not equal to 0, then A is non-homogeneous, right? Okay, so this is a kind of classification for a difference equation, and we have seen in this video that how difference equations are formulated and why they are formulated, right? And as we have seen, the solution can be found by iteration method. You can always use this iteration method, but this method is very long, or it is not always possible to find the nth term, right? So we need some concrete theory to find the solution of a difference equation, right? And again, using the same concept of differential equation, we have several methods to solve a homogeneous differential equation or a non-homogeneous differential equation. So same methods will be applied here, similar to those, right? And that will be the part of our next video. For this video, thanks.